My pseudonym is Skunkworks, and today I'm going to be talking to you about hard drive anti-forensics. My talk's entitled, "And That's How I Didn't Lose an Eye, Emergency Data Destruction." Oh yes, and by the way, the picture up there is what used to be a hard drive platter after some modified thermite was applied to it. It's, as I believe I said in my paper abstract, about as forensically useful as a wet noodle now. So first, a little bit about me. I'm an undergrad in electrical engineering at a major U.S. research university. I do a lot of, well, an insane amount of my own R&D outside of school in my basement in suburban Maryland. I'm experienced in basically everything from non-destructive entry to CUDA, VoIP to Tesla coils. I'm just a tinkerer. I love building stuff, and that's why I took on the Shmoo Group's hard drive data destruction challenge and succeeded in it. I'm cutting class to speak at ShmooCon. I actually had to cut Friday double E class to make the flight out. So starting out, I learned about the data destruction challenge that Potter, Olam, and Lawson put out at DEFCON. They gave a talk, and that's how I lost an eye, exploring emergency data destruction, where they talked about their own failures in designing a 3U rack mount server-sized hard drive enclosure that's capable of destroying a hard drive in 60 seconds or less without collateral damage. They failed pretty epically at it. I'm going to play the video in a second, and I decided to go ahead and pick this up because, you know, in Soviet DC, ShmooCon pay you. If I do this and speak here, I get the speaker's fee, and I just love building stuff. So the other thing with hard drive anti-forensics is there's this recent court case up in the Northwest. I forget exactly the title of it, but apparently Fifth Amendment rights do not apply to hard drives, according to this judge. So there's obviously a lot of interest in anti-forensics due to that also. Continuing on, video's worth, you know, if they say picture's worth 1,000 words, video's worth 1,000,000 or 2 to the 20 in binary. So I'm going to go ahead and play a video that's kind of the worst of the worst of the Shmoo Group's DEFCON presentation, where they, yeah, this is like the worst of the worst, but this is the lead up into how I started in anti-forensics for the hard drive challenge. And here we go. 1 second.
What are we doing here? Remotely destroy a drive. Just make the drive go away. And we wanted complete drive destruction, like a pile of slag. Like our first thought was thermite. Yeah, it's a lot of people's first thought because it's fun. You have a 1U server. You have 1U above and below to install whatever they want in the rack. So concrete, asbestos, you know, things like that. When you fire the hard drive, you have 60 seconds to destroy it. You must not set off fire suppression, smoke sensors, seismic sensors, because we're near banks. Must not harm other system in the rack, and you must not harm the humans that happen to be nearby when you're lighting off your thermite or magnesium or something like that. So there were certainly times when we thought something really bad was going to happen. So we initially split this up into 3 areas: incendiary, which was Deviant's area of focus; chemical, which was Shane; and physical, which is mine. We're going to go through the efficacy of each of these.
As Bruce pointed out, incendiary, it's because there's only 2 ways you can do this. One is thermite, which doesn't, you know, play nice with anything, or doesn't play nice with ceramics, which there's a lot of in circuitry and hard drive platters. So that really much just kind of leaves you with explosive blow the crap out of everything, which fails miserably at all the conditions we set for this situation.
So, moving right along, I don't have any great pictures or anything. So the point of the chemical destruction, I was going to spray a mist that goes into the platters, eats it away. You end up having a big bubbling pile of what used to be a platter. So how do I know it didn't work? Well, because it didn't work.
The slide's in the wrong spot, by the way.
Yeah.
Okay. Yes, there you go. So the idea with physical destruction was we were going to grind stuff down, hence the term physical destruction. Absolutely really nothing happens. Here's the kicker. We failed. We failed in a big, gnarly, nasty way. And awesome! That's what DEFCON Friday is all about. Yeah, woo! One person's excited, the rest of you like, we're going to beat him up in the alley later. We're going to get Lawrence Fishburne, and we're going to redo that scene from 21. Yeah, that's you.
So I was the one guy who was excited. I saw an opening here, data destruction challenge, and I was like, okay, Shmoo Group might have failed at this, but I want to try and do this. I want to try and do this properly. I'm going to build that 3U server. This is going to work. And I actually got a little cocky at first, and I've got to admit, starting off, I probably wasn't doing much better. I first figured, why not try lye, sodium hydroxide. It doesn't play very nicely with aluminum. If anyone's ever tried subjecting aluminum to a concentrated solution of sodium hydroxide, it fizzes and dissolves and puts out a lot of hydrogen gas. I figured hard drive platters made out of aluminum, just put some lye solution in there and that should take care of your forensics issue. Turns out that indeed the coating on hard drives is really resilient, and it's not only on the top, it's also on the sides, and basically the hard drive platter is just sealed 360, and unless there's a nick in it to start with, which isn't very conducive to an operational hard drive, lye is just not very viable. So I decided to kind of continue and maybe look at a couple new avenues. And that's when I decided to go with a high voltage transformer, generate some very high temperature plasma on the surface of the hard drive. And this actually did work. I ended up using a microwave oven transformer. For those who aren't familiar, that's around a 2.1 kilovolt transformer in the range of 700 to 2,000 watts, depending on the microwave. Have 120 volts in, as I said, 2.1 kV out, and it can jump a fairly good gap between two electrodes. I ended up using a couple very high current carbon motor brush electrodes, and I'd have them positioned on either side of the platter, one on the top, one on the bottom, and then I spun the platter up, and while the platter was spinning, I applied the high voltage arc, and that did a very good job of, it partially melted the platter and it completely charred the surface of it. The plasma generated was, I hear, 2 to 3 times hotter than the surface of the sun, usually for an arc like that, but regardless, it had no trouble destroying the platter. The main problem with that, though, is first off, you can't do it to a stock hard drive. You have to open up the hard drive in an ISO 5 clean room if you want long-term operation of the hard drive. And sure, an ISO 5 clean room is not the hardest thing in the world to get access to, but it kind of seems like winning a don't blink contest by starting with your eyes closed, in my opinion, even though I did technically meet the requirements. So I decided to kind of go back to the drawing board after this, even though it worked. And then there was also another really larger issue, aside from having to modify the hard drive, and that was the power problem. If you're just doing this to one hard drive, it's really not so much of an issue. But if you've got an entire data center that has to go away, well, all the hard drives have to go away in a matter of 60 seconds, you're going to be replacing your accounting department with a nuclear power plant as far as power requirements go. I mean, you're talking easily tens of megawatts to destroy thousands of hard drives, and that is just not viable, let alone if the bad guys who are storming your data center cut power. You're not going to be destroying those drives, given the way that there's so much energy required using electric arcs. So that's when I kind of went back to the drawing board and decided to think about things on a much kind of higher level. I broke it down into really two kind of facets to the problem. One was destroying the hard drive, the second was protecting the surroundings. So the first one, I just decided to think about, you start with a bunch of bits that are in order and mean something, and your goal is just to get to entropy. It doesn't really matter how you get there. You just need to take this platter and remove the order to the bits, and then you need to protect the surroundings if that is destructive enough and it doesn't just kill the platter. So incendiary really did seem the logical choice, some type of chemical incendiary that will melt the platter or just demagnetize it. And that's when I kind of started to get back into thermite work, because Shmoo Group never really tried thermite. I actually talked with Bruce yesterday. I heard the main reason was due to just the smoke, and that indeed was a large issue for me, but I finally eliminated that through 2 different ways. So, moving on, I ended up making a quick visit to Hackaday, and indeed, there's already been thermite data destruction done. This was featured on Hackaday something like 3 or 4 years ago. I'm not exactly sure on the time. But destruction is really only half the battle. I mean, you don't want that in your data center if you're a sysadmin. That is not only going to set off fire suppression, that's going to eat through the floor. It's going to set your whole data center on fire. That is just not viable. So you've obviously got a lot of issues in fire protection engineering here if you're going if you're going to be using stock thermite. So then we come to the not losing an eye part. Once I'd settled on thermite as an incendiary compound or a thermite derivative, I went ahead and purchased a full fire proximity suit off of eBay. Yes, and fire entry suit gloves. The gloves are actually rated for short duration contact to 2000 Fahrenheit. So as long as you're not placing a pile of thermite on your head and setting it off, this is very excellent at protecting you. If you ever watch Mythbusters episodes where they work with thermite, Jamie Heineman's always the one wearing this. So about 170 bucks off eBay. I had safety pretty well taken care of. And then I'd also like to add, throughout the course of my thermite experimentation, I was very careful about not setting fires in the surroundings. Whenever I was setting off amounts larger than around 10 grams that had the possibility of throwing off a lot of slag, a lot of sparks and the like, I would always do the experiment in a 4-foot deep pit dug in my backyard, and the pit, I cleared all flammable material in a 10-foot radius and had an 80-pound bag of concrete over top of the pit that could be deployed into it as sort of a scram measure if a reaction ever got out of hand. Fortunately, that never happened, plus I had plenty of fire extinguishers nearby. And that, on the safety side, really worked well. I didn't want to repeat all too many accidents you see on YouTube where people are just being idiotic with highly dangerous chemicals and something bad ends up happening. So much ado about thermite. Probably a lot of you aren't super familiar with thermite. I'd hope a lot of you have at least heard of it, but it's a lot hotter than the lava pictured. Thermite generally burns somewhere in the neighborhood of 3,000 to 4,000 Fahrenheit, depending on the exact composition. It's about 2/3 as hot as the surface of the sun, and it's also a very difficult reaction to initiate. It generally takes magnesium and electric arc or something else that burns at an insanely hot temperature. In fact, usually hotter than the thermite to set it off. You can have thermite glowing red hot and it will not go off. And for those of you who are curious, the exact chemistry behind regular thermite is 2.96 units by weight to 1 unit by weight of ferrous oxide to aluminum powder, and generally the finer the powder, the quicker the reaction is going to go, and also the easier it's going to be to set off. I used 30 micron powder on both for all of my initial experiments. Continuing on, I wanted to establish a baseline as to what reliably destroyed a hard drive. So I fired a series of, I believe, around 8 or 9 hard drives before I came to the realization that around 1 kilogram of thermite was necessary to reliably get a hard drive fully destroyed. I tried this with a bunch of different drives. I tried, everything from older 6-platter SCSI drives to some older single-platter like 40 gig IDEs to a few newer SATA drives, and everything basically between 1 and 6 platters I tried, and it seemed pretty universal that a kilogram was safe. Well, not as much safe as safe for destroying the data. Then the big problem with regular thermite is it tends not to stop with just destroying the hard drive. It produces a lot of molten steel, or molten iron actually in this case, not really any carbon in there, and that will go right through the hard drive in general. So when you're destroying the platter, usually you have a lot of burn through, and that can be, again, a huge issue if you're in a data center environment. Again, we get a lot of fire protection engineering issues, even though this kind of solves destroying the drive. So I decided to try and modify the regular thermite composition a bit. There are a few others out there. There's thermate TH3, which is common. That's about 26% by weight barium nitrate. That's used very commonly in military incendiary grenades for anti-material purposes. It's also, I've heard, been used a lot for destroying sensitive data like cryptographic equipment and other things that you just can't have reverse engineered if it gets into the wrong hands. So what I wanted was to modify the thermite composition in such a way that it would burn through the drive, but that it would do more damage to the drive than to anything else, and hopefully not burn through and set your data center on fire. What I decided would be a good strategy would be to have excess oxidizer, usually the ferrous oxide being the oxidizer in the aluminothermic regular thermite reaction. But ferrous oxide is not necessarily going to be super reactive in general as an oxidizer, so I was looking for something that maybe had a little bit of a lower melting and decomposition temperature. And this led me to a lot of exothermic research and development, which at least in the beginning was quite fun. So moving on, we've got calcium sulfate, which was a logical next step to replace some of the ferrous oxide as a bit of a higher temperature, more powerful oxidizer. Calcium sulfate-based thermite is indeed the most energetic kind that's commonly made. It burns a good bit hotter than regular thermite. It seemed a pretty logical choice for data destruction. The only interesting thing about it is I tried putting 200 grams of it on top of a hard drive, which with regular thermite is generally sufficient to enter the hard drive, albeit not destroy all the platters thoroughly, but enough to at least burn through. And despite the calcium sulfate-based thermite having more energy and burning hotter, it failed drive entry. And after looking at a lot of high-def videos of it, and watching a couple very small reactions in the 10-gram range up close in my fire proximity suit, I finally came to the conclusion that the reason it was doing this was it doesn't produce very much slag. The ferrous oxide and aluminum-based thermite produces a lot of slag in the form of iron and molten iron and aluminum oxide, whereas the calcium sulfate-based thermite produces mostly calcium sulfide and aluminum oxide, and that is not as, that slag has a much lower heat capacity, and as a result it tends not to burn through stuff as well, and you end up more with the thermite just kind of burning away on top, and only perhaps the last quarter inch of it or so that's on the very top of the drive actually does much to the hard drive. So with slag production too low with calcium sulfate alone, I decided to keep looking, and I kind of embarked on what's very familiar to computer scientists, a binary search. I don't have a PhD in computational chemistry. I can do basic stoichiometrics, but I was not about to come up with a ton of mathematical models for the ideal thermite for burning through a hard drive. So I just decided to start adding stuff to the mixture and see what it did in small quantities. And if it helped, I'd add more of it until it stopped helping. And if it didn't, I'd move on to something else. And I ended up going through a lot of different fuels and oxidizers. I'd do little tests on 18-gauge sheet steel. What I was looking for is something that burned the steel very well but didn't have that much pour through. It would burn it, but it wouldn't put a lot of molten slag through there that can continue on down lower and lower. The process involved, as I said, taking an additive and tweaking the concentration to find the optimal amount. And it actually got boring after a while. I ended up doing around 300 tests like this, where I'd be mixing in, minute quantities of a certain fuel and a certain oxidizer, and it ended up dragging out for a fairly long time before I finally settled on, actually I had things a little out of order, Thermex Composition 210. This was the 210th reaction that I tried. Thermite Experimental Composition 210, and this is 37.5% by weight regular thermite, 37.5 by weight calcium sulfate thermite, which is 1 part aluminum powder to, I believe, 2.45 calcium sulfate, and 25% by weight potassium nitrate, which is a little bit of a more volatile oxidizer that decomposes at a lower temperature and produces a lot of oxygen. Then going back, thermite is indeed very difficult to set off in general, and the Thermex mixture, Thermex C210 that I came up with was a little easier to set off because of the potassium nitrate having a rather low decomposition temperature on the order of, I think, a couple hundred C, maybe a little higher. But I cannot count the number of times that I saw blue hot magnesium sitting on top of a pile of thermite not igniting it. So in general, you don't have to worry about your thermite going off accidentally. It's more it not going off when it should. What I did ultimately settle on for ignition very reliably was a Marx generator. A lot of you are probably unfamiliar with this. It's mostly used in pulsed power applications. What this is basically a specialized capacitor bank that can charge up in parallel and then discharge in series, and that produces a very high voltage and a very high peak current, therefore very high peak power over a short period of time. And when you put that over a spark gap, you can produce an insanely hot spark that has no trouble igniting just about any fuel oxidizer mixture you can think up. The other interesting thing I found, which was a little unrelated, but I just decided to experiment a little, and that is that it's actually possible to set off thermite with black powder. Wikipedia says that this is not something that works, and indeed it does work. You can't just put black powder on top of thermite and set it off, but if you mix about 50-50 black powder to thermite, and then you put a little bit of pure black powder on top of that, I used a rather, I actually technically used something referred to as green powder because I omitted the sulfur and I mixed the potassium nitrate and charcoal separately and then mixed the powder together instead of milling the two. And that results in something that's burns at a much lower rate than regular black powder. But it was a rather interesting discovery that you can indeed set off thermite with black powder, just as a bit of a aside. There are also more exotic reactions you can use, like potassium permanganate and I believe glycol, and that will burn at a high enough temperature to initiate thermite, but I pretty much just settled on a Marx generator with a bunch of pulse capacitors for my experiments once I'd found that to be reliable. So moving on, I've actually got a video of the Thermex C210 in action. I will kill the audio because it sounds absolutely dreadful. But here we go. I'll skip to around 30 seconds in because I did use the black powder ignition method for this one. And please forgive me for the camera shake. I was wearing a fire proximity suit at the time. Let me see here. Oh, that's... Okay, there we go. And you're going to notice in a second here, the thermite actually catches. This is the Thermex C210. And this is how it burns. If you were to compare this to a regular thermite burn, you'd basically see that it produces a little bit less in the way of smoke than a regular thermite burn, and it burns a lot hotter and a bit more vigorously. It just goes a little faster. And there you can see, that's the entire pit. You've just got smoke rising out of it now, and that's about 200 grams, I think, that went off in there. Give it another sec. Whoa. Yeah, I opted not to bring a live demo today. Okay. So, moving back to the presentation. Okay. So that indeed succeeded in entering the hard drive. There I've got a picture from another test, just a still, of white hot calcium sulfate thermite, well, or Thermex. It's got calcium sulfate and potassium nitrate. And that's right after it's gone through the hard drive, and the hard drive is basically filled with slag. And you've got that little bit left on top. This is probably 10 seconds after I set it off. And it was very successful, completely anti-forensically destroyed the drive. There is no way you're going to get data off of it again. But that still leaves a big fire protection engineering challenge, and that's really the secret sauce in this. Destroying a hard drive with thermite is nothing that original. As I said, it's been done on Hackaday before. It's kind of more of a fire protection engineering here, but it was the hard part. The tedious part was mixing 300 some odd compositions of thermites to find the right one. So the goal is to take the data center and have it not turn into that. So containing the beast. I settled on fire-rated drywall pretty early because it melts at around 1500 C. While this is below the temperature that all the different thermite compositions I'm playing with melt at and burn at, it melts rather slowly in the presence of thermite. And in addition, there's a pretty interesting kind of exotic endothermic trick to the way fire-rated drywall works. And that is, fire-rated drywall is calcium sulfate, aka plaster, actually one of the components in my thermite, which is a little ironic. But the difference between the stuff in the thermite and the stuff in the drywall is the stuff in the thermite has absolutely no water in it. It's what's referred to as the gamma anhydrite phase of calcium sulfate. It only forms when you heat the partially hydrated phase above around 300 Celsius. But the gamma anhydrite version is quite reactive chemically in comparison to the hemihydrite. The hemihydrite version is what's in fire-rated drywall. And when the fire-rated drywall is in the presence of a fire, all that water slowly boils out of it, the hemihydrite, referring to the fact that for each calcium sulfate atom, there's an average, or each calcium sulfate molecule, sorry, obviously, there's an average of half a water molecule attached to it. And what happens when it's exposed to a fire is all that water very slowly boils off. And when that water boils off, that's an endothermic process. And what that basically means is that the drywall cools off as it's being heated and that water's being driven off. So the drywall actually takes a lot more energy to melt than an equal amount of just pure anhydrous calcium sulfate would. And that's kind of a bit of the secret sauce in fire-rated drywall and the reason why it was suitable for stopping the thermites like that. So I ended up building a prototype of this box. I just used 5/8 fire-rated drywall. In that one, a single thickness. And then I went ahead and set off some of the different thermites in it, and I found that even up to 400 grams sitting directly on top of it, there was not burn through, and in fact, the other side of it never got above around 200 Fahrenheit over the entire course of the test, which is quite good. Moving on then, there's still a big smoke issue. So that's, I had the box there, and ultimately for the first prototype, I sealed the top of the box and set off the thermite inside, but it still smokes. The smoke pours right out of the box. So what I ended up trying to do for the next version of the prototype, unfortunately I don't have pictures of the last couple. They're still sitting at home and I have not photographed them, but I just put an exhaust pipe on it, and that basically met the challenge, with the single caveat being you need to have access to exterior ventilation for the data center. So the box back there, it is 3U sized. It meets all the requirements on that, and with the top on and the exhaust pipe again being the only caveat, it meets the challenge, and all the smoke goes out the exhaust pipe instead of pouring out of it. Then moving on though, I did try putting a HEPA filter on it, where I'd take one of the sides off the box, and then instead of having the exhaust pipe, what I'd do is I'd have two steel baffles. One would be located about maybe halfway down the box, and the other would be located 3/4 of the way down the box, one on the top, one on the bottom. What the baffles do is prevent radiant heat transfer via infrared and visible radiation, and what that does is it prevents the HEPA filter from catching on fire. I did not learn this the hard way. I thought of it ahead of time. But then I was able to just take a section of HEPA filter, the type you put in your furnace, and just replace the outer wall with that, and that stopped all the smoke. Pleated paper HEPA filter. I did also try this with a fiberglass filter, and that actually does reduce some of the smoke, but it still failed pretty horribly. The smoke kind of poured out of the fiberglass, and that just wasn't a very good solution to the problem, but the HEPA pleated paper one did do it. So that's the Mark II prototype. I also did decide to go with double thickness fire-rated drywall because I had a lot of excess on the height and width for the 3U form factor. I mean, the box back there was 3U, but for the second one I basically just took the same box, layered some extra drywall inside, and then put up the baffles. And believe it or not, this is actually a rather boring process to watch. When the hard drive gets fired, it just, the box basically just sits there. You don't see anything. And no smoke pours out anymore. And as I think Bruce put it, what's the reason you don't want to use crypto on this? You just see the crypto and it's like, oh, it's crypto, yeah, it's working, yeah. This is actually kind of the same. You just hear a vague hissing noise and it's like, well, your data's gone. Data's gone, okay. And I did use a Marks generator with a couple wires leading in just for ignition on this one. But probably using some type of glow plug or some other exothermic composition to start things off would be a little better for a production model. The other important thing to point out is my prototype had a materials cost of somewhere in the neighborhood of $10. That's including the thermite, and that's a really cheap solution for a drive destruction, or a self-destruction feature on a hard drive. Like most of the hard drives that are currently marketed with self-destruct features in them retail for 2 or 3 times or even way more just for a hard drive with a self-destruct feature than a comparable drive without one. And this, in fact, seems to do it rather well in about, as I said, probably under $10 worth of cost. So I accidentally have a whole magnetism. It indeed does work, and I've got a hard drive I can actually pass around for a couple people after this. I'll pass it out after the talk. I've got this hard drive I just photographed, and there's basically nothing left of the platter material. There might be a bit in a couple spots, but I'm sure it's been past 800 C, which is the Curie point, and that was only actually with a 300 gram charge of the Thermex. If you move up to about 400 grams, you can't even really recognize the platter as much. But that's basically my prototype. So then going from there, kind of what are the lessons I've learned from this is probably going with a much larger unit that's made out of multiple layers of fire-rated drywall that's capable of containing a lot more hard drives would actually be the best kind of to get an economy of scale. I envision something more like a 20U sized unit, and then from that 20U sized unit you could perhaps put several layers of fire-rated drywall up, along with perhaps dozens of hard drives, many kilos of my Thermex or regular thermite. And there are, of course, self-destructing drives that are already out there, but I think something like this, if scaled up more instead of a single drive, or actually, if you look back here, I managed, oh no, I actually got 4 drives at 400 grams apiece without causing significant damage to my current prototype. But as I said, I think dozens of drives could possibly work in a much larger unit, and then you can really get economy of scale in place. The other very interesting thing I found is if you do have cleanroom access and the hard drive has enough extra space inside of the top of the case, which the majority of them do, you can actually get away with putting 10 grams of thermite directly inside the hard drive and use a binder, generally some type of plastic. I use polystyrene. And then the thermite with the binder inside the hard drive will destroy the hard drive without any outside collateral damage. You could actually have that hard drive sitting inside a server, and there's so little extra heat that makes it to the outside that it would not damage any other components most likely, and a very minimal amount of fireproofing would work. Perhaps you could even build a 2.5-inch laptop hard drive into what's usually a 3.5-inch drive enclosure, just to use a little bit of extra space for fireproofing and have a thermite charge built right into the drive. Again, though, this kind of would violate the initial challenge specifications, but I thought I'd throw it out there. So that's kind of the end of the talk. Actually, I'm a little bit early on time, but got any questions real quick? Okay, yeah? Can you speak up a little? Oh yes, the question was with the drywall, can I have a live system operating in there without the overheating issues coming up? And actually, I have not tried with an entire system inside there, but at least a single hard drive inside the drywall. If you have a rather long SATA cable running into the enclosure along with your power, the hard drive can just be in there no problem. If you were to have a live system operating in there, I still doubt it would be an issue. The fire-rated drywall is rather good at preventing radiant and conductive heat transfer, but I don't think that heat would be a huge issue unless you're running a bunch of GPUs or something inside there also. But frankly, there's no point in firing the entire server. You can just put the hard drive only in the box, have the cables run out of it, and save a lot of equipment costs if you do have to do self-destruction. So any more questions? Yep. Oh yes, this is definitely applicable to solid-state hard drives. They're destroyed at a far lower temperature than regular platters. I believe the flash memory can only survive up to maybe a couple hundred C tops, so that would be very easy to destroy them. I think you could even get by with a lot less reaction material, and perhaps a lot less fireproofing material also. Okay, anyone else? Oh yes, Oh yes, thus far I've only gone for horizontal mounting, but I can imagine you could possibly get it to work vertically. That just would take a bit of additional work. I'd imagine maybe casting a custom mold out of plaster to kind of guide the thermite into the drive then, in a bit of a J shape perhaps, where you have a stack of thermite and then the thermite would flow toward the face of the drive. Okay, yeah. No, I did not actually. I looked up my local fire codes and I didn't do anything in violation of them. Oh yes, well, I mean, it did put out a lot of smoke, but the rule up in Montgomery County where I was, I believe, was 18-inch flame radius, and I never exceeded that. And you can actually get a permit for bonfires and the like to go a little larger, but I never set off anything larger than that anyway. Oh yes. Yes, I definitely got a lot of looks from the neighbors walking around in a fire proximity suit. They're kind of like, huh, what's up with that? And I'm just like, oh, doing some research, you know. Just a bit of research. No, actually, I'm just wearing these because of the lights over there, but I wore welding goggles under the fire proximity suit the entire time, and I think I got less ultraviolet exposure over the course of my thermite experiments than you get taking a walk down K Street with your glasses off. Anyone else? Oh yeah, got someone where? Oh yeah, okay. Yes, that's actually an excellent point, and I'd meant to touch on that, in fact. Thanks a lot. The potassium nitrate ended up oxidizing the aluminum platters very well, and that's one of the reasons I had a lot less burn through using the custom Thermex C210, as I called it, than the regular thermite, because the hard drive actually participated in the thermite reaction, but didn't produce that much slag. So that was, yes, what ended up happening is all the slag that did make it into the hard drive had a huge surplus of oxidizer, and then after the coating was burnt off, the aluminum just basically rusted very quickly into aluminum oxide. Yep.
You talked a bit about using this in a data center.
Mm-hmm.
You didn't go much into the use scenarios, but this is more of a comment than a question. But one thing you can do is use disk encryption on all the machines that you're curious or wanting to protect, and then have a key management server that actually has all the keys for those. You know, the master keys you know, on the rest of them.
Yep.
And you only have to destroy those key management hard drives. You don't have to burn down your entire data.
Yeah, exactly. That is true. You could just have the keys on a key management server and just destroy that drive. That's a really great idea, actually, and then that would work really well. Yeah. Okay.
Okay, so as one of the jackasses that entirely failed, I'd like to applaud your research. You actually
Thanks a lot.
did research. You did it over a couple of weekends and a lot of alcohol. Really, just really a comment. Great work.
Thanks a lot.